and welcome to Physics Problems 1 by 1.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem also belongs to momentum playlist. Please read description, check the links, so you understand the previous prerequest and previous problem to better understand what I will say now. But basically what they ask from us is to derive the law of conservation of momentum from the formula for center mass. And of course the formula for center mass, let's say there are only two bodies, M1 and M2. And let's say we're interested only in this axis, X. And there is somewhere a center of mass. So this formula for center of mass is M1 x1 plus M2 x2 divided over M1 plus M2. And basically this is X. And let's say this is 0. Excuse me. This coordinate is x1, this coordinate is x2, so this distance is x1, this distance is x2, and then there is center of mass somewhere in between of those bodies. And this formula is m1 x1, and this is a formula. And they want to relate this to the law of conservation of momentum, to momentum. So basically, momentum deals with mv, this is momentum. So we have from coordinate to move to velocity. And so how we do it? We take a small time delta t, and for all of those x's we will be dealing with two, x final and x initial. So next moment something will happen and all of this will move. So we can say that if we say x center mass initial equal m1 x1 initial plus m2 x2 initial, so let's say those are those, divided over m1 plus m2. And then we do the same center mass final for this small period of time delta t. So I can draw it here and I can draw it here, and those would be x1 initial and this would be x1 final. And for all of this, I don't want to put them here because it will be impossible to read. So what I basically say is that final moment of this delta t, it would be all exactly the same. It would be m1 x1 final plus m2 x2 final divided over m1 plus m2. And let's say I move this here, which means multiply both sides of this equation on this bracket m1 plus m2. So if I multiply m1 plus m2 here, this will cancel out, but this will not cancel out, and the formula would be m1 plus m2. And then what I will do, I do in one step. I multiply this by this and this by this, and then I subtract from this. So I will say m1 plus m2, and then I subtract x center mass final minus x center mass initial. And here would be I subtracting from this and I grouping everything that relates to x1 and everything that relates to x2. So when I subtract this would be m1 x1 final minus x1 initial plus m2 x2 final minus x2 initial. And this would be this. Basically, I take subtraction. From this I subtract this, and simultaneously I multiply by m1 plus m2. So this is straightforward, m1 plus m2 and this minus this. And here when I take this minus this would be grouped. m1 factored out, and then the same here factored out. And then if I divide it all over delta t, so then I will receive m1 plus m2, and this would be this bracket, I don't want even to rewrite it, divided over delta t, equal m1, again, this bracket, divided over delta t, plus m2, this bracket, divided over delta t. And all I have is change in x would be velocity. So I will say m1 plus m2, and this would be velocity of the center of mass. And this would be differences in first body coordinates. So it would be m1 v1, and this would be m2 v2. And this is very familiar thing. If this thing imagines that there is a ball and total mass is m1 plus m2, and this is the center mass, so it has this momentum m1 plus m2 multiplied by v center mass. So we can imagine that center mass is some central point that the whole combination of those two bodies moves together. And this would be momentum of the first body, and this would be momentum of the second body. So basically, it's very much the same like a law of conservation of momentum. So this formula, and what happens when there are n bodies? So imagine that there is like n bodies, 1, 2, 3, 2, n bodies. Then the formula for center mass would be m1 x1 plus m2 x2 plus the last one mn xn divided over m1 plus m2 plus m3 plus mn. And this is the formula when there are more bodies than 2. It's the same formula. And this formula, you will meet it a lot because it's called weighted averages. Because this like average thing, but masses are different. If all the masses are the same, it would be like m1 equal m2. They all will cancel out, it will be x1 plus x2 over 2. Imagine m1 equal m2. They will cancel out, and this center mass would be x1 plus x2 divided into 2, because there would be 2 of those, right? But if masses are different, we kind of have to apply, they call different weights. It's not weights in the physics meaning of the word weights that we discussed. It's like weighted, that this is proportional to their masses. And the meaning of this formula is that if there is one body m, and this body is very heavy, let's say 1000 kilogram, and this is only one, then center of mass is located very close to the center of this heavy body. And this is visible from this formula. For example, if we want to say that one is 1000 and another is, we can have x center mass equal 1000 multiplied by x1 plus 1 multiplied by x2. And here would be 1001. Sum of two masses. So this would be negligibly small. And the coordinate of center mass would be very close, practically the same like x1. It would be a little bit different. This one will influence the position of the center mass. Like you sitting in the car. Your weight, your mass is very small compared to the mass of the car. Still, where you sit influences the center mass. Or you're riding the boat, sailboat. This is more important because you walk on the boat and center mass changes and you walk sideways and the boat inclines. So it's more tricky than that. But in general, and another thing that I have to add is that this is of course vector. So of course the same formula should be written for y center mass and z center mass if we're dealing with position of some body in the space in 3 dimensions. But all I wanted to show here is that this formula of center mass is tightly related to the law of conservation of momentum. And we should understand this. That's all for today. Like, subscribe, bell, and put your question. And see you next time. Thank you.